Okay, so here we need to explain some examples on continuity of functions. So a function is said to be continuous. The definition is that a real function f is said to be continuous if it is continuous at every point in the domain of f. If it is continuous at every point in the domain of f. So suppose, for example, if a function if a function f of x is having the domain interval a to b, where a and b belongs to real numbers. Then the continuity at the endpoints will be defined as, then the continuity at the endpoints a and b will be given as limit x tends to a minus, or limit x tends to a plus f of x, that should be equal to f of a, and limit x tends to b minus f of x, that should be equal to f of b. And the function is continuous if, and also the function is continuous if limit x tends to c f of x, that should be equal to f of c, for all values of c belongs to the interval a comma b, or interval, we can use the open interval here, open interval a to b. So it means that at the endpoints it should be continuous. At the endpoints b, if it is continuous, it means here b should be greater than a, obviously. So if it is continuous at the point b, it means that f of b should be equal to the left hand limit at b. It should be equal to the left hand limit at x equal to b. And if we have to define the continuity at the endpoint a, it means that f of a should be equal to the right hand limit at x equal to a. So then I will say that the function f of x is continuous in the closed interval a to b. Suppose, for example, if it is asked that is the function f of x equals to mod x, which is the absolute value of x, a continuous function or not? A continuous function or not? That you have to check. So the function f of x equal to the absolute value of x, that can be written as, that is equal to minus x if x is less than 0, and that is equal to x if x is greater than or equal to 0. So also, so now the left hand limit, so here we can see that, okay, so here limit x tends to c f of x, that is always equal to f of c for all values of x not equal to 0. Since if I for any value x less than 0, we can say that limit x tends to c f of x, that should be equal to limit x tends to c minus x, that is equal to minus c, which is equal to f of c only. And also for x greater than or equal x greater than 0, you can say that limit x tends to c f of x, that will be equal to limit x tends to c x, so that will be equal to c, which is equal to f of c. But for x equal to 0, we have to check the continuity. So now the left hand limit at x equal to 0, that will be equal to limit x tends to 0 f of x. So 0 minus f of x, so when it is slightly less than 0, so this will be limit h tends to 0 f of 0 minus h. So when it is slightly less than h, so then it will be limit h tends to 0, then it is minus x, so it will be minus of minus h. So that is 0. And the right hand limit of the function at x equal to 0, that is also equal to limit x tends to 0 plus f of x, that will be equal to limit h tends to 0 f of 0 plus h, that will be equal to limit h tends to 0 h, so that is equal to 0 only. And f of 0, that will be equal to 0 only. So now therefore limit x tends to 0 f of x, that is also equal to f of 0. So I can say, so the function f is also continuous at x equal to 0, continuous at x equal to 0, and at any other point other than 0 also, and also for all other real values of x. So here we can say the domain of the function f, the domain of the function f is the real number set, the set of real numbers. So therefore the function f is a continuous function. Since f is a continuous function, since it is continuous for all values of x belongs to R. And then suppose if it is asked, another example, that discuss the continuity, discuss the continuity of the function, discuss the continuity of the function f, which is defined by f of x equals to x plus 2 if x is less than or equal to 1, it is x minus 2 if x is greater than 1. So now here so now therefore you can see that for all values, for any value of x less than or equal to 1, you can say that limit x tends to c f of x, that is equal to limit x tends to c x plus 2, that is equal to c plus 2, which is equal to f of c. And also for any value of x greater than 1, you can say that limit x tends to c f of x, that will be equal to limit x tends to c x minus 2, that will be equal to c minus 2, which is equal to f of c. So therefore you can say that the function f of x is continuous, function f of x is continuous for all values of all real values of x except 1. except x equal to 1. Now we need to check the continuity at x equal to 1. So now therefore for x equal to 1, we have to check. So now therefore limit x tends to 1 minus f of x, that we have to find, which is the left hand limit of the function at x equal to 1. So that will be equal to limit h tends to 0 f of 1 minus h. So we need to write limit h tends to 0. So 1 minus h plus 2. So h equal to 0 if you put, that will be equal to 3. And which is equal to f of 1 also. And limit x tends to 1 plus f of x, that is equal to the right hand limit of the function at x equal to 1. So that will be equal to limit h tends to 0 f of 1 plus h. So we need to put 1 plus h. So we need to use the second definition. So that will be limit h tends to 0 1 plus h minus 2. So if you put h equal to 0, so this will be 1 minus 2, which is minus 1, which is not equal to f of 1. So now therefore the limit of the function does not exist. So therefore here we can see, therefore here limit x tends to 1, limit x tends to 1 f of x does not exist. Does not exist, but f of 1 is equal to 3. So therefore we can say, so the function f is not continuous at x equal to 1. So therefore we can say that x equal to 1 is a point of discontinuity of the function f. The point of discontinuity of the function f. So now so the limit x tends to 1 f of x does not exist. Since why? Since the left hand limit is not equal to the right hand limit. The right hand limit is coming minus 1 and the left hand limit is coming 3. So they are not same. Now therefore we have to now check we have to find the continuity of the function 1 by x. Suppose if it is asked that discuss the continuity of the function f, which is given by f of x equal to 1 by x minus 2, where x is not equal to 2. So here we can see, here the domain, so in the previous question we see that the domain of the function f is all real numbers r. But here the domain of the function f is not r, it is r minus 2. It means that 2 is not there, 2 is not included in the domain of the function f. So therefore we can see that the domain of the function f that can be written as, which is equal to minus infinity to 2 union 2 to infinity, like that. So if we have to check the continuity of the function at x equal to 2, it means we only have to find if the limit exists or not. So here we don't have to check the continuity of the function at x equal to 2. Since why? At x equal to 2 the function is not defined only. Now therefore limit x tends to c f of x, that is equal to limit x tends to c 1 by x minus 2, that is equal to 1 by c minus 2, so which is equal to f of c only for all values of x not equal to 2. So therefore we can say and since 2 is not included, we can write this, since 2 is not included in the domain of f, so we don't need to check the continuity of the function at x value 2. So we do not need to check the continuity of the function f at x equal to 2. So now therefore from here you can say that therefore the function f, therefore now you can see that the function f is continuous at all real values of x. Okay, yeah, at all real values of x which are included in the domain of f, so we can say that so the function f is a continuous function. So hope you have understood the concept. Thank you.